All right, so here we're looking at the exterior angles of polygons. Now we've already talked about the interior angles, and the interior angles are the angles inside a shape. But the exterior angles are different, and I think I'll show you over here. So if we take an equilateral triangle, equilateral meaning all the sides and angles are the same, so looks a little bit like that, then we already know that the angles inside a triangle add up to 180, which means the angles inside an equilateral triangle each have to be 60 degrees, because that way you have three angles, they're all 60 degrees, that makes 180, and they're all even. Those are the interior angles, but the exterior angles are what you get if you were to extend these lines outwards, like this. And the exterior angles are the angles formed on a straight line with the outside line that I've just drawn. So in this particular equilateral triangle, if the inside angle is 60, then because angles on a straight line add up to 180, this outside angle, the exterior angle, has to be 120 degrees because the inside one's 60. So they're on a straight line, they add up to 180. If I was to take a different shape, if I was to take let's take a square, then we know that all the angles inside a square are right angles. They are 90 degrees each. I'll just put some little squares in here. The exterior angles, again, we formed them by extending these lines outwards. And the exterior angles are the angles formed with the outside of the shape, like this. Now, if the interior angles of this shape are all 90 degrees, then because angles on a straight line are up to 180, then these angles outside have to be 180 take away 90, which is actually also 90. So I could have drawn squares there to show that they're 90 degrees. Now, I just want to show you, I want to point out something. If I were to add all these three angles together, if I was to do 120 plus 120 plus 120, I'm going to get 360. And if I do it for the square, if I add up 4 lots of 90 degrees, then I'm going to get 360 again. And in fact, for any shape, the exterior angles all add up to 360 degrees. For any shape. So here is a regular pentagon. It's got 5 sides and all the angles are the same length. So what we can do is work out how big each of these exterior angles is just by doing 360, which they all add up to together, and dividing it by 5, because they're all the same length and they're all the same angle, and there are 5 of them. So all these angles I'm drawing in red, they're all going to be whatever the answer to this is. And 360 divided by 5 is 72, which means each of these exterior angles of a pentagon is 72 degrees. Now, I could use that to do something else, actually. If I wanted to, I could use that to find out what the size of the interior angles are. Because, you know, for an equilateral triangle, we knew that it was going to be 60 degrees, each of the angles inside. We know that the angles in a square are 90, but I don't necessarily know what the angles inside a pentagon are. But I can work it out quite easily if I know that the exterior angles are 72. Because, like we said before, angles on a straight line make 180. All of these are on a straight line with the interior angles. So if I do 180 take away 72, what is 180 take away 72? Don't want to get that wrong. 180 take away 72 is 108. Oh yeah, should have known that. It's 108 degrees, so the interior angles of this pentagon are 108 degrees. Let's do that for another shape. Here is a hexagon. It's got 6 sides, and again, if I do 360 divided by 6 equals 60 degrees, then I've worked out how big each of these exterior angles are. They're all 60 degrees. And if I want to, I can use that to work out the size of the interior angles, the ones that are like this, by finding out what you need to add to 60 to get 180, because they're all on straight lines. So 180 take away 60 equals 120, which is the size of each of the interior angles. So I can work that out if I want to. One final example. Here is a 10-sided shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it doesn't matter that it's got loads of sides. I can do exactly the same thing. I can do 360 divided by 10, and that's going to give me 36. That's the size of the exterior angle that looks like this, or like this, all the way around. And I can work out the size of the interior angle if a question needed me to do that by doing 180 take away 36. So 180 take away 36 equals 144. So each of these interior angles is 144 all the way around. Like that, yeah. One final thing I'll just do in a corner here is that this also works the other way round. If I've been given a shape and I'm not told how many sides it's got, so if I'm given like a part of a shape like this, but you are told that the exterior angle is, let's say, 18 degrees, then you can work out how many sides it's got by seeing how many 18s it would take to get to 360. And the calculation for that is 360 divided by 18, which would give you 20, which means this shape has to have 20 sides because you need 20 of those 18s to get the 360, which the exterior angles always add up to. Right, so there's a question here. It's kind of a two-part question, but it's kind of two questions. If you want, you can pause here and have a go at that question, or you can just leave the video playing while I explain how to get the answer. So part A, the first question, find the size of the exterior angle of this regular octagon. So the exterior angle is what we've been talking about this whole time. It's the angle that looks like this, which we know always adds up to 360. So to find the size of each of them, I'm just going to do 360 divided by 8. Split it into 8. And 360 divided by 8 is 45 degrees. So each of these exterior angles is 45 degrees. It then says, use your answer to work out the size of the interior angles of the octagon. Now I'm just going to go back to my diagram. The interior angles look like this. So the angles are like in here. And because they're on a straight line with the exterior angles, they are what you add to 45 to get 180. So I'm going to do 180, take away 45, to get 135 degrees. That's the size of each of the interior angles of this octagon. So that's exterior angles, and I've shown you a bit about how it links to the interior angles. They add up to 180. But the key fact for exterior angles is that the angles on the outside that you make by kind of pinwheeling the angles round, by drawing these extra lines here, the exterior angles always add up to 360. That's it. Hope that helps.